In this video, we are going to go over a couple of more parallelogram area problems, and they're a little bit more, not difficult, but a little different than some of the area problems we first went over. So let's check it out. In this first problem, we are asked to find the area of this parallelogram. What is a little different is that I've given you the height in a little strange way, right? That height is 10 centimeters, and we know it's the height because it makes a right angle with one of the two bases here. So what that means is, in looking at this problem, the 12 centimeters does not matter. What matters is the height, which makes a right angle to the base that it corresponds to. So let's start out with our formula. Always start out with that idea. We have that the area of a parallelogram, if you recall from previous video, is the base times the height. And as we just discussed, the base and the height have to make right angles. So we know the base is 4 centimeters because it makes a right angle to the 10 centimeters. So the base is going to be 4, and we're going to multiply that by the height, which is 10 centimeters. Sweet. 4 times 10 is equal to 40, and that's it. That's all we've got. It's not a long problem, but it's one that we need to be careful of to make sure that we're identifying what the proper base and heights are. Now, does 12 centimeters have a height that goes with it? Absolutely. It's not drawn in this picture, but it would be the line that connects this base to that base there in a right angle. All right, let's jump to the second problem, shall we? We shall. In this problem, we are actually asked to find the missing height, which is kind of an interesting problem, and I'm going to give you a little bit more information in here. I'll give you that the area of the figure is 1,500 square feet. So I've given you this height, I've given you this base is 75 and that base is 25 feet. And of course, as usual, I have not drawn this figure to scale, meaning it's not drawn perfectly where this is actually a third of the length of that. My bad. Okay, so let's find that height. First things first, let's start out with our formula as we did in the last problem. The formula would relate the area to the base and the height by saying the area of the parallelogram is equal to the base times the height. Now from here, we should enter in the information that we have into this formula, our template for working, based on the information that we have in the figure. So we have that the area is 1,500 square feet. So I'll start out with that with A. Now, the question is, what is the base? Because we know that we don't know the height. That's what the unknown amount is. Is the base going to be 25 feet? Or is it going to be 75 feet? Well, again, like in the last problem, the base and height that we want to use here are the base and height that make a right angle with each other. This height makes a right angle with that base. So, as I take off a piece of that parallelogram, so these two pieces are going together, the 25 and the h. So we have base times height, or 25 times h. 25 times h. Now from here, all we have left to do is solve a little bit of algebra. So we just need to undo 25 times h and we'll have our answer. We undo that by dividing both sides by 25. So I'll divide both sides by 25. And you can either use your calculator or your supreme brain. First things first, recognizing that the 25s divide out and you're left with h is equivalent to 60. And the units are going to be in feet because we're finding a single dimension length. That's it. A couple more examples for you about finding the area or the height given the area of parallelograms. It's sweet stuff. I hope that you rocked it.